Bill here, Computer Science 221, and I wanted to go over a couple of homework problems. I gave you some homework problems to look at, told you that these might be good problems to look at for the upcoming quiz. There'll be one on Monday. Specifically, I asked you to look at 4.7 and 4.8. I think that these are important and illustrative problems here. So I thought that I would go over them here right now. So first of all, I want to take a look at 4.7. 4.7, they give you an instruction that looks like this. And they say to you that it's broken up into a few pieces. There is an opcode over here. Then they talk about there is something called SR. I assume that that stands for a source register. There is something called a DR, which I assume stands for a destination register. And there's something over here that they call IMM. And let's see, they give you a couple of pieces of information about this computer. First of all, it says that it is a 32-bit instruction. And that's an important piece of information. They're telling you that this is the format of it, and they're giving us a little more information over there. It says there are 60 opcodes. And it says to us that there were 32 registers. So they want to know what is the range of IMM. And they said let's assume, what do they assume? It's a 2's complement value. So the way that I would look at that is I have to ask myself, well, how many bits does the instruction occupy? How many bits do the opcodes occupy? How many bits do the registers occupy? Okay, so we know we have a total of 32-bit instructions. If I have 60 opcodes, well, I know with 1 bit, I could have 2 opcodes. With 2 bits, I could have 4. With 3, I could have 8. With 4 bits, I could have 16 opcodes. With 5 bits, I could have 32 opcodes. Well, I need 60. With 6 bits, I could do 64. Okay, so I know that what I need here is I need 6 bits for the opcode. So this over here is going to be 6. Okay, I have 32 registers. Well, I can come back here and look at the same calculation I did here. For 32 registers, I need 5 bits. So that means that the source register can take up 5, and the destination register can take up 5. And what's left over here, if I have a total of 32, this would be 32 minus 6 plus 5 plus 5. That's equal to 32 minus 16 is equal to 20. Okay. Oh, I made a mistake. Just want to see if you're all listening. This should be a 32. I'm going to get rid of all of this because this is just nonsense, this calculation here. We had 32 bits. Minus 5 plus 5 is 10 plus 6 is 16. That leaves me 16 bits left over. Okay, so IMM is 16. And the question is okay, so what is the range of IMM? Okay, so you have to figure out Well, we know that the range, the biggest positive number I could put in there would be this. Okay, there were 15 of these. That would be the biggest positive number. And what would be the biggest negative number? My guess would be the biggest negative number would probably be this. Some of you may be wondering, could that be a 0? Yeah, maybe. But the question is so what is the range of this? Well, that's 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048. Let me just, so that's 2048. So this is, I'm going to start rounding off now because that's good enough for me. That's 4,000, that's 18,000, that's about 16,000. Okay, but remember, I'm adding all of these up. So I'm adding up 16,000 plus 8,000 plus 4,000 plus, and this gets me approximately to 32,000. Okay. So the range of this thing over here, that this is positive 32,000. This is going to be minus approximately minus 32,000. So the range is plus or minus 32,000 for the IMM. And that is the answer. Okay, I think I'm recording. Yes, I am. I'm going to come over here and now we'll do 4.8. And let's get a nice big, there we are. 4.8 is a similar question here. So in 4.8, we're given the format of an instruction. We're told that this is 32 bits. And it's broken up as follows. There is an opcode. We are told that there is a destination register. We are told there is something called source register 1. There is something called source register 2. Source register 2. And then very interestingly, we're told that there's some part of this instruction that is unused. Okay. And we're given some information here. We're told that there are 225, 225 opcodes. We are told that there are 120 registers. And we are asked what is the minimum number of bits required for the opcode? So what is for the opcode? Well, again, we're going to do a calculation just like we did before with 1 bit. I could have 2 opcodes with 2 bits. I could have 4 with 3 bits. I could have 8 opcodes with 4 bits. I could have 16 with 5 bits. I could have 32 with 6 bits. I could have 64 with 7 bits. I could have 128, and with 8 bits, I could have 256. So the minimum number of bits that I would need for the opcode would be 8 bits. 7 is not enough. So the answer to this is 8 bits. Part B, they ask us, what is the minimum number of bits required to represent the destination register? Minimum number of bits for the destination register. Well, again, I note that there are 120 registers, okay? And by this calculation I did over here in part A, I see that 7 bits would be enough for the destination register. So the answer here would be 7 bits. So C is, what is the maximum number what is the maximum number of unused bits? Well, we can see coming up here, just looking at our previous answers, we know that the answer for the opcode is 8. We know that for each one of these registers, I would have to use 7. So this is going to be 32 minus 8 plus 7 plus 7 plus 7. That's equal to 32 minus, well, that's 21 plus 8 is 29. That's equal to 3. So the maximum number of unused bits would be 3 bits. Okay? And that answers problem 4.8. The point of 4.7 and 4.8 is that hardware impacts software. And likewise, software impacts hardware. The idea being that when you're designing a computer, when you make decisions like how big are the instruction sizes, how many registers are there, how many operations are you going to have, that impacts the size of everything. The size of the instruction impacts how many registers you can have or how many instructions you can have. Conversely, how many instructions you have, how many registers you have will impact the size of an instruction. So these two things here are very, very interrelated with each other. And I think that I know that that's the point that the author is trying to make to you. Okay, that's it for these two problems. I am going to end this video as soon as I figure out how. Right there. Bye-bye.